Now let's look at a car that's accelerating. First of all, let's see the car speeding up while it's moving to the right. If it's speeding up, then its motion and acceleration directions must be the same as one another. So it's moving to the right. We've decided that right is positive, so its acceleration is also positive. The position time graph for accelerated motion is curved. So notice here we have the car moving to the right, getting faster and faster and faster and faster. Now let's look at the graphs. The position time graph curves upward. As it gets faster and faster, the graph becomes steeper and steeper. The velocity time graph has a regular gradient sloping upward, so it's got a positive gradient but one uniform gradient because the velocity is not changing, and the velocity is always positive, meaning it's moving to the right. The position is always on the right, that's why the xt graph is always above the zero line. The velocity time graph is also always above the zero line because it's heading to the right all the time. There's a positive acceleration. It's speeding up while moving in the positive direction. When it's speeding up, its acceleration and its velocity must be the same direction. Now let's make the car move to the left. The whole time it's going to be to the right of the zero line. So its position is always positive, but it's heading towards the left, so its velocity is left. Its velocity is negative. It starts off slow and it gets faster and faster. It's speeding up. The position time graph starts high up because it starts far away from the reference point and then ends at the reference point because it's moving from the right to the left. The gradient of the position time graph starts shallow and gets steeper and steeper and steeper as it speeds up, as it gets faster and faster. The velocity is always negative. The velocity graph is always below the line, below the zero line. What does that negative velocity mean? It means the car is always heading towards the left, which we chose to be the negative direction. Because the car is speeding up, its acceleration's direction has to be the same as its motion's direction. The motion's direction is negative. It's heading to the left, so the acceleration direction is also negative. So we have a constant negative value for acceleration. Now let's have two situations where the car is slowing down. So the acceleration must be opposite to the direction of motion. We let the right direction be positive. So both of them slow down. In the first case, I'm going to make the car move to the right. In the second case, the car is going to move to the left. Therefore, the acceleration must be the opposite because it's slowing down. Negative for the first situation, positive for the second. So here the car moves to the right and gets slower and slower. So its position time graph starts at 0 at the reference point and rises as it gets further and further away from the reference point. But it's always above the 0 line because it's only ever to the right of the reference point. We're never making the car move to the left. So that's why its position is always positive. Its velocity is also positive. We can see that the gradient of the xt graph is a positive gradient. The velocity is always positive, meaning it's always heading to the positive direction. It's always heading to the right, moving to the right. We can see that the velocity is changing. Starts off fast and gets slower and slower. The gradient of the xt graph starts steep and gets shallow and shallower. The gradient of the xt graph tells us velocity, fast velocity, slower, slower. And so we can see from the velocity time graph, indeed it is decelerating, starts at 10 meters per second and gets slower and slower until 0 meters per second. So because it's slowing down, the acceleration's direction must be opposite to motion. Motion was to the right, positive, acceleration must be negative. So this has negative acceleration. And it is also decelerating. But negative acceleration does not mean the same thing as deceleration. Now let's have the car moving to the left, not to the right, and also slowing down. So we can see it starts far on the right, 50 meters from the reference point on the right, and it moves to the left, getting slower and slower. So the position time graph starts at 50 meters and slopes downward. So the velocity, the gradient of the graph, is negative because it's going downward. It's heading to the left, in other words, heading to the negative direction. The gradient of the xt graph becomes shallower and shallower. It starts steep when it's going quickly, and it goes slower and slower. The gradient becomes shallower and shallower. That's because the velocity is slowing down. It's decelerating. The velocity is always negative because it's always heading to the left, heading to the negative. Motion is negative. The velocity starts quick. Negative 10 meters per second is quick. Don't think that that negative means less than 0. It doesn't mean less than 0, meaning slower than standing still. No, the negative in velocity means which direction it's heading. It's got nothing to do with magnitude, how fast it's going. It's only got to do with which direction it's heading. So it's heading in the negative direction. When we start observing, it's doing that very quickly. And then it gets slower and slower, but all the time moving in the negative direction until it stands still eventually. So it's decelerating. Whenever an object gets slower, decelerates, its acceleration direction is opposite to motion. The motion direction was negative, the velocity was negative. It was heading to the left. And so the acceleration now must be positive. So it has positive acceleration. Even though it is decelerating, the acceleration is positive. Another way to look at this is the car was going its fastest when it was at the right, most positive position. And so its acceleration is positive because the acceleration means which side was it fastest. It was fastest on the positive side. So in summary, when an object is speeding up, its acceleration direction is the same as its direction of motion. When an object is slowing down, it is accelerating in the opposite direction to its motion.
And before we go, have you already liked? Have you subscribed? Have you left me a comment? And please go and visit my website. You'll find a lot of resources there, and they're categorized in a way that will make it very easy for you to find what you need. Until we meet again, learn science!